Hi everyone, it's Sia. This is a presentation of my Pioneers Abstract, Intuitive Autonomy for Real Users of Small Unmanned Aerial Vehicles. Let's go. Small unmanned aerial vehicles or UAVs are becoming more prevalent and autonomous in their operations. However, like any other autonomous system, these too can fail in many ways and under varying contexts requiring transition of control between autonomous and manual operations. During this process, users may be required to both take over control from and cede control to autonomy. But who are the real users of UAVs? They are the researchers like us working on UAV technology and interaction. They are agriculturists monitoring crop health with a UAV. They are hobbyists who can go buy a UAV off the shelf and start flying it. These users have wildly different amounts of experience and training expectations in operating the UAV. The situation presents a challenge and an opportunity for designers of these systems because it means that their products are being broadly employed, but there's simultaneously a greater need to understand the spectrum of user responses. The first part of the research discussed in this paper is focused on investigating the ability of operators to resume control from automated flights. Through a 75-participant study, we examined transfer of control between user and autonomy, failures over 3 different deadlines, noise in operation, user training, and responsibility to fix failures. We will build on initial work by exploring complexity of failures, involvement in task, complacency effects, takeover options, and decision aids. While not central to the hypothesis of the initial study, participant classification by proficiency in piloting UAVs became a difficult problem to solve. Hence, second part of this research is focused on being able to assess user proficiency in piloting autonomous systems. We conducted an exploratory flight test study with 8 participants which revealed that user performance was affected not only by experience in terms of flight hours, but also by the type of controller used. We will take this work forward by investigating the different factors contributing to user proficiency in line-of-sight UAV operation by taking into consideration specific experience that users may possess. A holistic understanding of users' ability to control and monitor UAVs, take over control in case of system failure, and leverage assistive technologies to effectively mitigate danger will help inform better training and instruction methods and build high-performance advanced assistive autonomy, leading to our future interactions being safer.